Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Split linked list in parts, Leetcode 725. In this problem, we are given the head of a singly linked list and an integer k, and we need to split the linked list into k consecutive linked list parts. And note that k can be greater than n, where n is the number of nodes in the linked list. The length of each part should be as equal as possible. That is, no two parts should have a size differing by more than 1. Some parts may be null if there aren't enough nodes to distribute. For example, when k is greater than n. The parts should be in order of occurrence in the linked list, and parts occurring earlier should always have a size greater than or equal to parts occurring later. And we should return an array of k parts. Then in example 1, for the given linked list and k equal to 5, we split the linked list into 5 parts because k is equal to 5, and first 3 part contains one node each from the original linked list, and last 2 parts are empty. So that is our answer. Similarly, in example 2, for the given linked list and k equal to 3, we split the linked list into 3 parts, where first part has 4 elements and next 2 part have 3 elements each. So we return the array of 3 linked list. So we are basically splitting the linked list, and that's why the elements occur in the order of the occurrence of the input list. And if we can't split the linked list in equal parts, then earlier parts are larger and differ by size of at most 1 from the upcoming parts. Now in terms of solution, they want us to split the linked list into equal parts if possible. So that means we divide the linked list size, let's call it n, by k to get k equal parts. And this will be the minimum guaranteed size of each part. Let's denote it by m. So for example, if linked list has 10 nodes and k is equal to 3, that means each part will have a minimum guaranteed size 3. That means each part will have the minimum guaranteed size of, but it may leave some remainder nodes that still needs to be distributed. Let's call it r, and that will be n modulo k, right? Because modulo operator gives us the remainder. In this example, we can see that remainder will be only 1 because 10 modulo 3 is 1. So we need to divide these remainder nodes one by one to each part starting from the 0th node till we distribute all of them. Now let's see this in action. So in example 1, n is equal to 3 because we have only 3 nodes in the linked list, and k is equal to 5. So base size of each part will be n by k equal to 0, and our remainder will be equal to 3, right? So that means we will divide the linked list into k, that is 5 parts of size 0 each initially, and distribute remaining 1 node each from the remainder starting from the 0th part. So that means first 3 parts will have 1 node each and the remaining 2 parts will stay empty. So we will start adding the nodes to the list. So first we will add 1, then we will add 2 to part 2 and 3 to part 3, and now it is equal to remainder. So that means now we don't have any nodes remaining and we will return this as our answer. So this is for example 1. Similarly, let's take example 2. N is equal to 10 here, k is equal to 3. So that means we have to divide linked list with 10 nodes into 3 parts, and then minimum guaranteed size of each part will be m is equal to 10 by 3, that is 3. And what will be the remaining node? That will be only 1. So all the parts get 3 nodes each. And because we have one remaining node, we have to distribute it. So we start from the 0th part again. And the first part now will have 4 nodes, that is base size plus 1. And now we have used all the remaining nodes. So we can split the linked list into 3 parts, with first part having 4 nodes and remaining parts having 3 nodes each. So it will become 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that will be our answer. So our algorithm will be to calculate the length of the linked list, then determine the size of each part by first calculating the base size, dividing the linked list size by k, and then use remainder to find the actual size, and finally populate those parts by traversing on the linked list. And even though the math was easy, this is still a medium problem because while traversing the linked list, we have to handle the edge cases like null pointer exceptions. And for that, let's jump into the code part. So first thing we will do is get the length of the linked list. And let's assume there is a function called size that takes head and returns the length of the linked list. We will write it later on. And then we calculate the minimum guaranteed size of each part and the remainder that we need to distribute starting from the 0th part. And now we can define our answer parts, the array of linked list containing k parts. We should also define the current pointer to traverse the linked list. Initially, it will be pointing to head. Now we will loop from I equal to 0 to k and try to fill in k parts. So first thing we will do is we will initialize the ith part by setting the current node as the start of the current part. But we still need to split the linked list after we have assigned the nodes for this part. So let's do that now. And for that, we will determine the size of the current part. So it will be whatever is the minimum guaranteed size, that is m, plus 1 if I is less than r, otherwise it should be 0. And the reason is we have to assign remaining extra node, that is r, to the first r parts. So in this case, part size will be m plus 1. So if we have 3 nodes remaining and we have 5 parts, then we will distribute 1 each to initial 3 parts. If part number is 0, 1 or 2, we will be assigning 1 extra node to that part. So that's why the part size is m plus 1 in that case. Otherwise, it will be m only because we don't have any nodes remaining. And now that we have calculated the size of each part, let's traverse the linked list and split it accordingly. So we have already populated one node, that is current. So we will start from j equal to 1 and j less than part size. And we will just do current is equal to current dot next. But while going to the next node, we can also get a null pointer exception. So we should also check if current is not equal to null. Then we can continue to traverse on the linked list. And now that we have traversed the linked list with the desired length, we can split the linked list. But again, we have to check if current is not equal to null. But before splitting the list, let's get the next pointer. Otherwise, we cannot continue with our iteration and we may still need to fill in other parts. And now we can reset our current to next pointer for the next iteration. And finally, we should return the parts array. And now let's define our size function. It takes head of the linked list and returns number of nodes in the linked list. So initially length will be equal to 0. And we will again use current pointer to iterate on the list. Initially it will be pointing to head. And now we will start looping on the list until we have not reached the end of the list. That is until current is not equal to null. So we increment the length by 1 as we encountered a new node. And finally, we will return the length of the linked list. Now let's run this code. Let's submit this code. Cool. In terms of time complexity, it will be O of maximum of n and k, where n is the length of the linked list and k is number of parts we have to return. And the reason for this is, even though this looks like a nested loop, we are going through each node only once, right? And if k is less than n, that is number of parts is less than number of nodes in the linked list, then we will be looping through all the elements in the linked list. So it will be O of n. But in case k is more than n, like in example 1, then again we will loop through all the elements in the linked list. But we are also running outer iteration k number of times. So in this case, the time complexity will be O of k. So whatever is the maximum value between k and n, that will be our time complexity. And in terms of space complexity, it is O of k, where k is the number of parts, because we use an array of size k to store the head nodes of split parts. So that's it. I hope this video was useful to you. If it was, please give it a thumbs up and subscribe to our channel for more coding tutorials. If you have any question or suggestion, please write them in the comment box. The code link is in the description below. Thank you for watching. Happy coding.